change of internal energy is equal to heat plus the work. But what kind of work? Well, there's all types of work. You could do electrical, you can do compression expansion work, which is really important. Let's just kind of separate them. There's a reason why we want to make them two separate phenomena. So we have the compression expansion work and we have, well, other work. Could be electrical, could be mechanical, God knows what else. Sub in these two equations together. Would you look at that? Have a nice, neat equation. The change in enthalpy of our system is equal to the heat supplied to the system and any other work. We're excluding all the expansion and compression-based work. That's really interesting. This means that the change in enthalpy is only caused by the heat supplied to the system and due to any other work outside of compression expansion work. That is why the symbol for enthalpy is H. I believe the lore is that Gibbs gave it the phrase. I have it written down. It was originally defined as the heat function for constant pressure. H for heat. The reason why this equation is so useful in the end. In chemistry, enthalpy is also measured in a very similar way. You will have enthalpy values for certain reactions, ionizations, and so on and so forth. They use it for everything. Delta H is equal to the enthalpy of the products minus the enthalpy of the reaction. Ay, ay, ay. Ask you to do one thing, lab rats.
And they call it a mine.
A mine! Oh my god, we just started a stream. God damn it. Where's the thing? There's a button here. Oh, where's my button? Found it.
Choo choo!
And they call it a mine. A mine!
Motherfucking choo choo!
Thank you so much for the hype train, lab rats. Welcome in after weeks and weeks of not seeing any of these. Oh, it's so good to be back. So good to be back. A little bit of normalcy in life is great. Valiant Otter, thank you so much for 19 months. Let's go. Harry for 22. Herder, thank you so much for your 100 bits. Black Shard for 31 months. Also, please go to bed. What the heck? Zir, thank you so much for 27 months. Yes, 27 is divisible by 9. You're absolutely right. I'm confirming your mathematics. Oh. Opinionat, welcome in, welcome in. Hello, Zir, Black Shard, Harry, Mord, Herder, Valiant Otter, Dan. I'm going through the chat now. Swallowed, hello, hello. Zir, welcome. I just say Zir. Adav.
Mr. Anderson.
It's not that loud! Oh my god! You're not ripping anyone's ear off now, Tarek. Let's go! Yashas, welcome in, welcome in. Oh hey, and Merry Birthiversary. How'd you know it's my birthday tomorrow? Oh, I posted in Discord. But, okay. Yeah. Anyways, tomorrow's my birthday. Unless... Are there any Australians here? And it's the 9th already. Is it the 9th for anyone yet? Is it though? Is it? It is my birthday tomorrow, yes. I was planning on doing some special streams and... That's right! Me and Bees have birthdays back to back. And we were born within minutes of each other, it turns out, because I was born just after midnight and she was born just before. So it wasn't maybe minutes, it was hours. And what about very old friends? Lind, thank you so much for the tier 2 at 31 months. Spicy Bashra, thank you so much. It's 20 minutes past midnight in Fiji. There we go, there we go. That's right, I remember that story. We found out that me and Bees were born hours apart. Hours apart. Really, if you think about it, me and Bees are just polar opposites of each other. I don't know where I'm going with this. Oh, it's so good to be back. I don't sound too nasally, do I? I took a bunch of Strepsil and some medicine, and I'll be putting stuff up my nose. Now, before anyone clips that out of context, in case anyone's wondering what I'm putting up my nose, I'm just putting a little bit of, just for a little bit of blockage. I don't know if you all have this kind of medicine, but we have this kind of thing. We're doing drugs. Exactly, Nana. We're doing drugs live on stream. Welcome in, Harold Spark. Hello, Star. Hello, Raymond. Welcome in, Daniel.
Potatoes.
Boil them, mash them, stick them in a stew. What can we do when we boil them and mash them and stick them in a stew? There's nothing else we can do except celebrate it. Tarek, thank you so much for completing the level 2 hype train. Thank you so much for your biddies. Hello, Theo. Welcome in. Insert snort noises. Oh my god, my house looks so bad. I have so many syringes lying around, and we got a lot of medicine for Bambi, but they weren't able to like give it to us in medicine form, so we had to buy tablets and we had to crush them. And I swear to God, if any random person walks into the house, they're gonna think we're like druggies in here or something. It's crazy. But yeah, a lot of the syringes just get stuck very easily, so we have to keep replacing the syringes. So we have a lot of syringes. Dodgy tofu household at the moment. Thank you so much for the hype train. Really appreciate the financial support, lab rats. Now more than ever, so many things happening. You know that figure of speech, when it rains, it pours? Is that an Irish figure of speech or an English one? I feel like anything associated with rain is just associated with Ireland. But I'm not sure if you guys are aware of that figure of speech. And just, unfortunately, a lot of bad stuff happened. Nothing, look, it's fine. It's life. It all just happened in less than a month. I'll update you over the months of what's going on. I just have to sort out some affairs and figure stuff out. But yeah, there'll be a plan in motion. We'll deal with the things as we go along. They'll be okay in the end. Father Dougal, Cassie, welcome in. Thank you, William. You're very kind that you enjoy my lectures. Today's lecture is going to be a bit weird. I picked a topic that I want to do a YouTube video series on. And the topic I'm doing is the physics of biology. Now, did I get the title right? Did I do physics of biology or the biology of physics? Because those are two different things, mind you. The physics of biology. Yeah, no. We got the title right. Hi, Brute. How are you? How is Lana? The physics of biology. Hey, Spooky. Welcome in. We've a lot of spookies. We've at least 3 active spooky chatters. Very popular username to have spooky in your name. Hello, Professor. Hello, Fiat. Welcome in. We are many. We are one. Hope chat is doing fabulous. Hope everyone is doing well. I'm doing much better. Today's the first day I don't need to take ibuprofen, so a win. Well, we'll see. Maybe if I stream longer, I might start sweating, and I might. Sorry, I touched my armpits. I'm already kind of sweating a bit. We'll see. We might need to take some ibuprofen later. But like I said, I'll be putting stuff up my nose. Don't judge me, and maybe some strepsils. We'll keep it on the low end if we can. Hi, Medjay. How are you doing? Welcome in. How are you getting on? I hope you're keeping well. Basically, the universe's way of programming robots using atoms. Yeah, so a little while ago, when I was coming up with problems for my students, I ran across some really interesting mathematical problems. A mine! Physics problems specifically, and they were like about blood pressure, about the heart, about the lungs, and I thought, you know what, let me find my 5 favorite ones and do a little series on them. I think that'll be fun. So you guys help me find a couple of problems, number 1. Number 2, yeah, I guess that's it. Conrad, thank you so much for the Has it only been 12 months? I swear you've been here longer. But anyways, 1 whole year. Thank you so much for your support. We appreciate the medicine. Maybe not for me, but Bambi, I swear, the 2 times she got sick were the 2 times I was like, yes, this is the first month I can save money. Finally, don't have a wedding. I don't have a huge house expenditure. I can save money. Then Bambi gets sick and it's so pricey. So pricey. It did have 12 months. That's right, Bathroom. Welcome in. Hi, Slayer. Hi, Logitech Gal. What do you mean only? I just feel like you've been here longer, Conrad, honestly. Hi, Nexus. Thank you so much for the support, Lab Rats. I really, really do appreciate it. I want to celebrate my birthday tomorrow. I am going to stream because I can't leave the house. I was originally going to plan, you know, Nathan and I were thinking about going to a restaurant and celebrating. But unfortunately, because of Bambi, we can't leave her longer than 2 hours at a time. So we have to stay home. And I did have a few like interesting streams planned, but yeah, life's been a bit too hectic lately, unfortunately. So I don't know if I have the enthusiasm to do something special. We'll see. We'll see. Maybe I will. I'll try to do something fun tomorrow. Bit of banter, bit of crack. Happy early birthday. Thank you. Thank you. Yes, tomorrow we're celebrating our 31st birthday. We're getting old. Getting very old. Soon there won't be much of a tofu left. I'm going to get some textbook ready. Physics textbook here. Oh! I can really pop my arm.
No, thank you. We don't want any more visitors, well-wishers, or distant relations.
And what about very old friends? Very old friends indeed for me. It is almost a year. Thank you so much for the resub. You reminded me about the Labra passes. They have been printed. I just need to go into town next week and pick them up. So we're moving. Slowly, things are moving. So yeah. Just do what I do and be 22 every year. 22 plus or minus. Our margin of error increases with each year. With those textbooks, why does Nate have a gym? Great question. Fucking hardbacks as well. They're heavy as heck. Heavy as heck. So yeah, I'm gonna see if I can find some problems. I feel like I saw some really nice heart problems and stuff. And blood problems. But I think do you know what I need? I need my laptop. I need the electronic copy of this book. So I can do, you know, the Control F button. You know what I'm talking about? Laptop here. This. Hey. Other than Bambi, obviously almost dying on me, I did have a nice time in Riga. I did get, on my last day in Riga, I got a cold and I got food poisoning. That was the most torturous plane ride in my life. 3.5 hours on a plane with food poisoning. I was in so much pain. It was awful. It was awful. To be honest, I didn't vomit that much at all. I just felt like I needed it all the time, but I didn't actually do it. And just like really, really bad tummy pain. But other than that, yeah, we got through it and really rough. And then obviously we picked up Bambi and Bambi was like almost dying on me. It was such a fucking awful Sunday. Hey Crimson, hey Lotus. How am I more than 15 and a half years older than Tofu? Ah well, what can you do? The importance is how productive or how much more prosperous your 15 and a half years over me are. Well, not over me. That sounds bad. That sounds competitive. Should never compete against anyone, even yourself. Or should you compete against yourself? I don't know. What do you think, lab rats? Oh, it's our first August stream as well. Oof. Did the Latvian health services survive a Russia-Irish? They did. They did. It was a 2-day wedding. I didn't make it to day 2. I unfortunately did not make the second day, pretty much. I was so hungover, and I was the worst hungover person at that wedding. So I feel a bit embarrassed about that. Not much, but, you know, I just feel bad that I wasted a day hungover. In fact, it was actually so impactful, like me getting so hungover, that I don't know if this is going to be a blanket statement for now, but I actually have decided to stop drinking. Now, this isn't like, oh, you know, I'm making the declaration I'll never drink again, but, you know, I'm just not doing my casual weekend drink that I usually have. All those statistics and lore about, you know, a glass of wine an evening helping your heart supposedly have all been falsified.
They call it a mine. A mine!
Good choice. I hope so. I hope so. We have a few streakers, by the way, I missed. Corby with 305. All of Sutton with a 10 stream streak. Did I miss anyone else? I hope I didn't miss anyone else. Because there's no sound, I miss it. Wrongtown, thank you so much for tier 3 at 11 months. You know what? We really appreciate the tier 3 sub. That's amazing. Did I post a little photo of Bambi getting sick? She got an x-ray. She went to a proper exotic vet. They did an x-ray on a rabbit. Have you ever seen how a rabbit gets an x-ray? They have these 2 pillars like this, and they put the rabbit in there, and they put straps down to make sure the rabbit doesn't move. Oh, the poor baby. She must have been so stressed. So thank you so much for the resubs. I'm going to be honest with you. All the financial support is going to Bambi because she's costing me an arm and a leg, honestly. Rabbit medication, it turns out, is not cheap. No. So she's on 5 different meds. Yeah, 6 if you count critical care. But like each vial is like €100. Really expensive medication for her. Yeah, kind of like a chew Wrongtown, exactly. Hi Cobra, welcome in, welcome in. Again, like I said, she's really good this morning. This morning we had huge success. She pooped loads. Her gut is moving. It's not great. She's still not eating as well as she should. Her poop isn't as great as, but her gut's moving. We've gotten over the huge hurdle, basically, and we're not out of the woods, but we see a clearing. Pooped a shit ton last night. No pun intended. They were very good poops as well. Very stinky. Yeah, I know it sounds like a bit TMI, but for rabbits, it's really important they poop a lot. Rabbits poop 300 times a day. 300 pellets. So they poop a lot. They're like cows. They always have to be eating. They never stop chewing and eating, and their tummy has to keep working. So much so that they even eat their own poop sometimes. Sorry, I keep getting distracted. I need to pick up my book. Guam? No, that's not the I reference. How you doing, Bulbadum? So I'm gonna have to take a break in about half an hour. So in half an hour, we're gonna go upstairs and we're going to syringe feed Bambi a few of her medicine. I'm gonna take some sugary gut syrup, and we're gonna take some peptides, some probiotics. You know the yogurts that you eat at home, like for your gut health, like Activia. We're basically giving her Activia, specifically for bunnies. Hi, Maggie, welcome in. Yeah, it's sugary syrup, which is really great. They put a lot of flavorings in these stuff so that Bambi will actually lick it. We put a syringe right up to her mouth and she licks it. She's actually very good. She's been very good taking her medicine. She's getting a bit more fussy now because she's a lot more energy. But before, when she was very lethargic and, very weak, she wouldn't fight us at all. But now she has fight. Now she's thumping me and now she's flicking me. The brat. I should have known there was something wrong with her. The boarding place. And I do not blame the boarding place. It's just rabbits. Rabbits are very sensitive creatures. They did very good taking her to the vet immediately. They delayed it. Anything could have gone wrong. I should have noticed something was wrong because they reported, Bambi's so sweet. She's so cuddly and lovely. And I was like, that bitch is not cuddly and lovely. She's evil. I mean, we love her. Let's be fair. We all love Bambi. But she's not cuddly and lovely. So I should have clicked immediately that something was wrong with Bambi when he said that. Oh, look, we live and we learn. We live and we learn. Do you know what I'm actually eating? Not Activia now. I bought cottage cheese. Well, not real cottage cheese. So all the Eastern Europeans, you guys know what I'm talking about. What I bought is tvorog. So in my local Spar, they have a little Polish section and they actually sell tvorog, which I think is it like, the English word for it is like curd cheese, curdled cheese maybe? Hi Lana, welcome in. Yeah, we have a Spar. Yeah, very good one here. Oh, no, it's not Spar. Feck. We do have Spars. Super value. Cheese curds. Is it cheese curds? How's your Masquerade Bloodlines going? Hi, Mythic Frost. Oh, there's a whole chapter. Applications in biology and medicine. Whoa! There's actually a whole section in this book. Back off. Oh, it's just a reference. That's actually really nice. I'll keep this reference up. So I have the physical book, but this guy will have a few references of where we can have biology examples. That's fantastic. Yeah, Cassie, I'm not a big fan of what happened here. I'm not sure. There's a few issues I have with this t-shirt. I'm not a big fan. So, I think this is meant to be the sun. Then it's Mercury, Venus, Earth, Mars. But look at Jupiter and Saturn. Sorry, I'm pointing at my boob. Relax. But look at Jupiter and Saturn. I don't like the relative size of them, and the sun as well. Like, I don't like the relativity. Like, it's okay if they're not perfect in ratio, but why are they so... So, I don't know, maybe it was like an artistic take, number one. Number two, I hate to say this. Yeah, I don't know. When I saw this, I was kind of disappointed about the ratio. Hi, Krishermis. Welcome in. Perseids? No, I did not see any. We're going to go try and see... It gotta be... Yeah, because I was going to say something else. Something accusatory, and I will be careful. But the problem is if it's accusatory... I I feel like I wouldn't have gotten this wrong. I think this was an artistic choice. Exactly, that's what I was thinking. It's okay for it not to be to scale, but the size order is a bit weird. We'll see the Perseus till the 13th. Isn't the eclipse happening on the 12th as well? If I'm not mistaken, we have the eclipse happening on the 12th. My textbook. There's so many amazing biology examples. Really, really cool. I think it's on the 12th, random. No worries, Wrong Town. Thank you so much again for your resub. Really appreciate the support. Ireland is getting near totality. Oh, okay. It would be cool to check it out. I think we're gonna go. When is the 12th again? What day? Wednesday, is it? That's a Wednesday, yeah. On my phone on me, I need to check the calendar. But I think we'll go there. That'll be cool.
Pull the lever, Kronk.
Wrong lever! Yeah, I remember some sort of eclipse happening when I was in primary school, so I haven't seen an eclipse in a long time. It'd be really cool to see. That would be cool. Okay. There's some really cool examples of biology here. There's centrifuge, torque with muscles, teeth straightening, human body stability, blood flow. Love a good blood flow. Blood loss in the brain, pressure in cells. You know what? Let's look at that. 200. We'll look at a few of these examples. I want to see mathematical examples, not just conceptual ones. Oh, the eclipse glasses. They're like black with a little pinhole. Is that the ones? I might bring my camera and everything and record it if I can. Last lunar eclipse was 1999, was the day I got married. I should have read the galactic. Was that a good thing, X-rays, or a bad thing? Okay, this is definitely not the right thing. Shit. Okay. I guess I have a different, This is inertia. How has this got to do with anything with pressure of blood cells? Ooh, there's a Coriolis effect derivation. That's fun. I might get a sticky note. That looks cool. Where are my sticky notes? This is just for myself. I found something. Yeah, the pages don't line up because I have a different version of the physical book. It could be a nice YouTube video, actually, or a very nice short just to explain how the eclipses work and what we see. It might be a bit of a stretch. It might be a nice video to explain why we know the Earth is round and how this is only possible, and if the Earth was flat, other than obviously gravity and stuff, we wouldn't see these kind of things, but... I don't know. I'm always nervous about those kind of things. Yeah, it seems like my my textbook does not line up with With my online textbook, unfortunately. So it's actually going to be very hard to find stuff. What I might is, oh, sorry. So I might just see what happens. There we go, fluid. There we go. Blood flow. I have a problem here on blood flow. Oh, it's a mathematical problem. Let's go. We have our first mathematical problem. Coriolis forces are cool. For me, what's the thing that I really liked about it? It's a really important weather aspect equation to take part in, as in like when you're trying to measure wind or like predict wind formation. I remember in my earth science module, it was really, really good. Is there a table of contents in the physical? Oh, there is. Daniel, very, very smart. There's contents, but it doesn't have that example. I think it's because this model is really, really old. I could be wrong. Available supplements. Color. Yeah, so my physical copy is super old, I think. That's the problem. And by super old, I mean... See how old it is? What year it came out? Okay, it's not too bad. 2000. 2000. It came out in the year 2000. Not too bad. Year 3000. Not much has changed, but we live underwater. And your great, great, great granddaughter. Pretty fine. Sorry. The Airbender series is faithful to the original anime. Oh, sorry, I missed a lot of chat. What are we going on? We're talking about anime? I'm not very good at anime. Neurobiology on my own. I recommend looking into how neurons work with equivalents. Yes, I actually did do a huge study on that, Lint. Because I have a mixed bachelor's degree and we did a special study specifically on that. Some really cool maths in it. We'll see if we can do some stuff for it. That'd be really, really cool. Okay, so here's the first problem I see, and it's about blood flow. We're big fans of blood flow, and it's about fluids. In humans, blood goes into the heart, into the aorta, from which it passes the major arteries. These branches into small arteries, arterioles, which in turn branch into myriads of tiny capillaries. The blood returns to the heart via the veins. The radius of the aorta is about 1.2 centimeter. Fuck off! Is it that massive? The radius... No! You're joking me. That's not real. The radius of the aorta is about 1.2 I need to check this. That's massive. Holy shit. That's huge. You can stick a finger in it. You can do more than that. Okay, don't think where your brains are going there, but Jesus. Oh my God. That is huge.
No, thank you. We don't want any more visitors, well-wishers, or distant relations.
And what about very old friends?
Hey, Tetsu. Yeah, we were perfect timing for you to come in. Sorry, Daniel, your comment got blocked for AI, not AI, for TOS, but it's fine. I don't know why it got flagged. Damn! This is why biology, like, a physicist doing a bit of biology is a lot of fun, clearly, because holy shit! That is so cool. Lurk away, guys. Welcome in, everyone. Sorry, I didn't say hello to so many people. Tetsu, Blast Rainer, welcome in. Tetsu, by the way, thank you so much for tier 2 at 76 months. Huge support. We were talking earlier. Welcome in, Code Shudder, Random Logic. Yeah, we really appreciate all the bits and subs now more than ever. Our finances are very... I'm not struggling, it's fine. But Van Be Sure loves to test my banking balance these days. And you know what? This is important. I really, really hope to highlight, like, I'm very lucky that I don't have kids at the moment. And you know, both Nathan and I are working, but if anyone had a rabbit and they're tight on budget, like, you know, really, really important reflection that pets are expensive. To take care of your pets well, they're expensive. I know Berserk. Oh, wow. I didn't know about the author. I really liked the movie episodes. Do you know the 3-part movie of Berserk? Like is a strong word. It's a very... I watched Berserk and my heart broke watching it. Final finale. Like... When I say the newer ones, it's the ones that are 15 years old. Hi, Grim. Welcome in, welcome in. Yeah, it was such... You know, I'm sure you guys know the meme, top 10 anime betrayals of all time. I mean, Jesus Christ, it broke me. It was one of the last-ish animes that I watched before I kind of stopped being an anime head. Okay, sorry. I got so distracted by the fact that our aorta is 1.2 centimeters in radius. Fucking massive. Anyways, a typical capillary has a radius of about 4 by 10 to the minus 4, and blood flows through it at a speed of 5 by 10 to the power 4 meters per second. Oh, and sorry. And the blood passing through the aorta goes at a speed of about 40 centimeters per second. Holy shit! In 1 second! It pumps this fast! Are you looking... This is the amazing part when a physicist studies biology for a bit. First of all, the size of our aorta is 1.2 centimeters in radius. Okay, it's almost 3 centimeters in diameter. That's a pipe. Number 2, it pumps blood this much in length in 1 second. That's amazing. Our bodies are class. Holy smokes. So cool. Okay, thank you, Cassie, for looking it up for me. Because I would not know that. Ava? Ava. Iova. Probably the closest I would say the pronunciation is. Ah, no, you're making it up! I fell for it. Okay, let's go. What's the Irish for aorta? Aorta, on aorta. The problem with the Irish language is that it's a very old language, right? and we lost a lot of it. It was lost due to, you know, a lot of nations being forced not to speak it. And obviously the English language and your language, whatever you speak, Russian, German, whatever you speak at home, that your language evolved with technology and science. Because of the resurrection of the Irish language, there's actually a huge jump in the old Irish and more modern Irish. And because of that, most more modern words, we just don't have words. And what's fascinating is in the realm of science and PhDs, I know of a few colleagues who quite literally did their PhD thesis as Gaeilge. They did it in Irish. And because they're doing something very niche in the realm of electrochemistry or biochemistry or physics, they actually have to make up words as Gaeilge to explain certain phenomena because no one has done this. It's a very, very raw and new thing. What's also really exciting is that if you do your thesis as Gaeilge, your thesis examiners have to be fluent Irish speakers. And so how many lectures in your realm of science, okay, that's already pretty niche, not just in physics, but in your niche of physics, speak Irish fluently and at a level of at an academic level. So yeah, that's really, really exciting, of course, but it is funny to think about as well. Yeah, a lot of my colleagues who did their PhDs this way came up with like 20 new words themselves, which is kind of cool. Number 2, Frank McCourt. Hi, Caveman. Hi, Nikki. Welcome in. I hope you're doing well. Long time no see is what I want to say, but I butchered it and put it together. Ah, of course, of course. English is hence more convenient. Oh, I see, Kruta. That's interesting. Estimate the number of Oh, this is a very interesting question. Love this question. Okay, so the aorta is the big tube in the heart. And then the capillaries are in the thousands. I don't know if it's in the thousands or the millions. I have no idea how many capillaries we have. All over our body. Okay? So we know that the aorta is 1.2 centimeters in radius. And we do know that it is pumping blood at 40 centimeters per second. Really, really fast. Now, a typical capillary has a radius of about 4 by 10 to the minus 4 centimeters. That is 0.04 millimeters in radius. That's really, really small. And the blood flows through that capillary at 5 by 10 to the minus 4 meters per second. Very, very slow. Estimate the number of capillaries that are in the body. That's a really nice question. So in this case, what we're basically using, I don't have the proper solution equation here. I think we're using the equation of continuity kind of thing. It's like we need density, area, and speed, right? Okay, we have some sort of solution here. Maybe we should cover the theory first a little bit. Ah, it is the occasion of continuity. Look at me! I know some stuff. Oh, thank you, Tarek. Really, really appreciate that. Have a look. It might be easier than looking at my laptop the whole time. Where did it open? I pressed open link and then it died on me. We'll keep doing it this way for now until my laptop dies. No, we don't assume flow rate is the same. In the capillaries, it's super slow. It's 5 by 10 to the minus 4 meters per second. It's much slower in the capillaries. Makes sense. Yeah, no, that's correct, Gulden Smith. That's exactly the question I asked. What is considered a capillary? Like, what is a capillary? Is it an unbroken branch or yeah, I'm not sure. Maybe someone. Yeah. Just trying to help AI along. Ever look into English? Oh no, I've heard of it, Magus, but no, I haven't read it yet. Okay. Oh, this is so cool. Sorry, I'm really I really love these kind of examples. They're so interesting. Yeah, we can come up with an example. What time is this? 2 o'clock. So it's time for Bunzo's medicines, but Nathan's still in the shower. But we're going to change a few of the examples because obviously, first of all, this is theft. It's not. We talked about this before about copying problems from textbooks. I'm going to change the problems a little bit so that I don't completely copyright it. Number 2, I'm not showing the textbook. Number 3, I credit the textbook. Hopefully the copyright gods don't go after me. I feel like I've covered my ass, no? Number 1, I do the reference. I tell you where I got it from. Number 2, I don't show the text. So there's nothing on my image that shows it. And number 3, I change the numbers in the mathematical problem. Or I change something in the mathematical problem. I hope so. I hope so, Smith. I know it sounds like tough you're being pedantic, but listen. Can we change the number? Oh, true. You are so... That's such a lovely idea, to change the numbers to make them as a rabbit. The reason why I won't do that is just because I would like it to be more friendly for students. I think the size of our aorta was class. The bunnies is going to be much smaller. It's not going to be that impressive. I think the fact that our heart tubes are so big. Oh my god, like, seconds, I have some. I actually have a printed model of the heart for a vase. This is a vase. Like, even in this 3D model, is it 3 centimeters in diameter? Like, no, it's nowhere near this big. Like, even in this model. Amazing. Yeah. Ah, there we go, random logic. You're very good at writing exam questions. Have you seen the ChatGPT a body video? No, I don't know. I'm not I don't do stuff with ChatGPT. I'm not sure. Not really interested in that kind of stuff. Okay. The radius of the aorta is about 1.2 centimeters. I don't know. And I googled it really quickly there to double check, and it can be anywhere between 1 to 1.5 centimeters. Okay, so what we might do is we might solve this problem together. So I'm going to change a few of the figures, and we ourselves are going to solve it. We'll see how far we get. Like I said, as soon as Nathan's out of the shower, I have to go and give medicine to Bambi. It's a 10-minute break, 10 to 15. I really would appreciate the support that if you guys could stick around. Really, really means a lot by helping out this community at the moment. So what we're going to do is we are going to go upstairs. We're going to syringe feed her. It won't be too bad. It won't take too long. Try and get her to eat. And yeah, after that, it's every 2 hours we have to syringe feed. So it shouldn't take too long. Let me pick you up, guys. That's basically what I'm doing, Random Logic. I'm coming up with ideas for my exam papers. I shouldn't be saying that out loud. Although, this is the benefit, right? My students watch my stream. They get a bit of a snipe to the possible questions they get in the exam paper. The problem is all of these things are live and my students haven't arrived yet. New freshman students aren't arriving until next year. Okay, so let's say that the aorta (1.3 centimeters). And the speed of pump that (0.39 meters per second). Hey, Daniel Monkey, thank you so much for the 70 stream streak. You're very, very good. What else? We'll say that the capillary radius let's actually Google it. What's the typical capillary radius? Google this. Typical. So about 4 micrometers. Okay. Yeah, no, that's right, Daniel. Micrometers, and then the speed caps is 5 by 10 to the minus 4. Okay, so I changed only 2 numbers. I changed the format of others, just switching it up a little bit. Problems a bit. So, estimate the number of capillaries that are in the body. So clearly, what's going on? We have the main chamber of the heart. Like this, right? And one of the aorta where the blood is being pumping. It's a huge tube, basically. And a lot of very, very fast blood is pumping around. Now, in your body, you've loads and loads of capillaries. I have no idea how much. We're going to calculate how much. But there's many, and they're super, super thin. And obviously, the blood isn't going to flow anywhere near as fast in them as it does in others. Why? Well, the continuity. Right? Go to you now. Markers. Got to do with this little. You have a big tube, small tube coming out. Get the equation right before I spout nonsense. There is a derivation to this, but the continuity equation is reliant on three things. That if the fluid is incompressible, that's another assumption. Okay. So, it's dependent on two things. Like story A, 1, 2, pipe, flow of a liquid fluid. We have the density, speed, the area, the cross-sectional area. The cross-sectional area, sorry, you're right, I am cutting out on the mic. Let me increase the gain. If we slash this part here, and we look into it, it's a circle. That's why we say radius. We look into it, just a circle or a sphere or whatever circular looking thing it is in there. So there is a proportionality between the density, the velocity, area, also equal to the density of the next object, or the next fluid, velocity, and the area. Now, in this case, we're going to ignore density because in most situations, the liquid is incompressible. So what we're going to do is, we're going to get rid of those two. So the only two things that we're going to care about is V1, A1, and V2, A2. There's something weird about this equation, chat. Look at, if we just sub in those numbers really quick, you're going to find something dodge, aren't we? What are we going to find out? Anyone kind of see the big problem? Oh, sorry, I'm blocking it. Anyone see the major problem in this case? We do need a constant. Why? Yeah, we'll calculate the area from the radius. That will become pi r squared. That's okay, yeah. So when you sub in all your numbers, they're not going to be equal to each other. Zero's right, there's going to be a constant there. But where's that constant coming from? And the number of capillaries, exactly. The thing is, those two things are obviously not going to be true. In reality, if you just grab a normal pipe like this, right? You have a big pipe, there's water flowing, and then a thin pipe. What happens to the water in the thinner pipe? You have a thick pipe connected to a smaller pipe. What happens to the speed of the water in the thinner pipe? If anyone has like I'm not very good at this kind of thing. Velocity increases exactly random logic. You're absolutely right. We know that it's going to go whoosh, super fast. It's turbulent. Or it could be laminar, but you know, it's going to go super fast. But that's not the case in our body. Our heart is pumping to our capillaries, which are smaller, but it goes slower. And the reason why is because there's only one aorta. Am I right in saying that? Do we only have one aorta? Can anyone correct me on that? Well, we have a shit ton of capillaries. So, whichever one where we're putting the numbers for the capillaries, we'll put n the number of capillaries. And this is how we can calculate the number of capillaries. So what I'm going to do is I'm going to take a break here and feed Bambi. What I'm going to do is I'm going to leave this problem on the board. Could you guys estimate for me the number of capillaries in our body, assuming that the cross-sectional area is a circle? That'd be a nice problem to get you to solve. Okay, thank you for confirming that we only have one aorta. I know I studied biology, but I'm not very good at it. I forgot it. Forgot a lot of my biology. Yes, we're ignoring lung capillaries. Alright, I'll see you in a bit. I think. I'm not sure. Let's pretend I am. Let's pretend I know what I'm talking about. I'll be right back. Get you some time to solve it.
tender caress to bind our fortunes. Damn what the stars are. Rend my heart open, then your love profess. A winding, weaving fate to which we both atone. You flee.
That still only counts as one.
Your scent, berries tart, lilac sweet. To dream of raven locks and twisted, stormy, of violet eyes glistening as you weep. The wolf I will follow into the storm to find your heart, its passion displaced by our ever-growing, hardening into stone. Amidst the cold to hold you in a heated embrace, you flee. My dream come the morning, your scent, berries tart, lilac sweet. To dream of raven locks and twisted, stormy, of violet eyes glistening as you weep. I know not if fate would have us live as one, or if by love's blind chance we've been bound. The wish I whispered when it all began, did it forge a love you might
That still only counts as one.
flee? My dream come the morning, your scent, berries tart, lilac sweet. To dream of raven locks and twisted, stormy, of violet eyes glistening as you weep.
Hi! I hope you guys didn't miss me too much. Sorry for keeping you waiting for so long. Welcome back. Thank you, thank you. Oh, I was gone, yeah, almost 15 minutes. No? Not even. Good to know. Good to know that's how long it takes. So yeah, we gave Bambi medicine. She only took 3 syringes of critical care. Not too much, but she ate a bit of dill, a bit of parsley, and she peed, so all good. All good. Thanks for the follows as well. Okay, so I left you with a mathematical problem to solve while I was away. And let's solve it together.
And they call it a mine.
Seattle Green, thank you so much for
mine.
9 months. Let's go. 9 months is a heck of a lot of time. Is a heck of a lot of time. That's a Twitch Baba. Thank you so much for the support in this channel. It really means a lot. Thank you. The whiteboard really intrigues, does it? Okay. There we go. It's a biological milestone as well. Wink, wink. Yes, we have many biological milestones right now. Okay, so what I'm going to do is I'm going to rearrange the equation to find n on its own. So in this case, V2 and A2 has to be the capillary. In fact, I'm going to replace VC and AC for the capillary and V1 and A1 with aorta. Letter A. So we're going to rearrange that equation. VA AA over VC AC equal to the number of capillaries. Okay? Now we need to sub in the values, but we don't have the area. We do have, obviously, pi r squared. So what we can do is we can make that VA pi r a squared all over VC pi r c squared. Another handy thing that we can do is we can actually cancel off the pi's. Nobody gets a pi. I know, very, very sad. Hi, Fizir. Hi, NDCR. Welcome in, welcome in. Hello, Rathanil, by the way. And Ildanen, hello. Keep, hello. I hope you guys are having a wonderful Saturday. Thank you so much for spending it with us while we're doing the physics biology problems. Bonjour, Lizard, bonjour. Nobody gets pi. The pi's cancel. Hi, Evandriel. But I want pie. What's your favorite pie? When we say pie, it's such a broad term. It can be pastry, like a sweet thing. It can be savory. And I guess it depends if you're American or British. It really comes off, yeah. Because what's the difference between a pie and a tart when it comes to sweet stuff? Anyways, sidetrack. Let's sub in our numbers. The velocity of the aorta was 0.39 meters per second. And the radius of the aorta was 1.3 centimeters. We need it in the right units. 0.013, all to be squared. All divided by the velocity of the capillary, which is 5 by 10 to the minus 4. And the radius of the capillaries on average is 4 micrometers. 4 micrometers is 4 by 10 to the minus. To be squared. There we go. So let's grab our calculators, if any of you have calculators. Scheiße. Where did I put my calculator? If I were Tofu's calculator, where would I go? Where would I abandon her in her hour of need? Aha! Shall we approximate? I hate approximating too much. But no, we should have. So 0.39 multiplied by 0.13 all to be squared divided by 5 by 10 to the power of minus 4 in brackets 10 to the minus, 4 by 10 to the minus 6 all to be squared. Whew, we got a huge number. We're going to see if we got it right though. We'll do approximation to get it right. So I got a whole damn lot of capillaries. Let's see. Let's make sure that we're correct. I don't know if you can see that. 8.239 by 10 to the power of 9. Okay, so how to double check? So if this is squared, we go back. So we're minus 2, minus 1, minus 4, about minus 5 here. So I'm just making sure we're in the right dimension. Minus 6, minus 12. Minus 12, minus 4, minus 16. 5 and 16 goes... Oh my god. 11? Did I do that wrong? No, it is 11. Did I get that wrong? Did I get this wrong? I like how your shirt doesn't have the poser Pluto on it. Did I get the wrong dimensions? About 9. Let's try one more time. Did anyone else get answer? Yeah, that's the same answer I'm getting, Daniel. Okay, so Daniel's getting the same answer as me. Did anyone else get the same answer as me? Pluto slander. -5. Yeah, that's right dimension. Oh, okay. No, I see my mistake. I see my mistake in my approximations. Yeah, okay. All good. All good. Never forgotten. I still don't know if this is the correct answer, but my approximation is fine. Did anyone else get 8 billion capillaries? Yeah, -15 is a denom. Yeah. You're right about that. The math seems okay. Alright, we have apparently almost 8.5 billion capillaries. We'll say 8.2. Let's Google this. Let's find out
And they call
how
it
many
a
capillaries
A mine.
are there in the human body. This will be interesting. Let me bring you all down to my level. Almost a year. Hi, Steve. Thank you so much for the resub. Really, really appreciate that support on this channel. Thank you. The resubs and the bits today mean so much. You've no idea, lab rats. No idea. Thank you so much for the support. Okay. Okay, so it depends apparently on the definition of a capillary. But about 10 billion, yeah. Not bad, not bad. Pretty close,
No,
pretty close.
Thank you. We don't want any more visitors, well-wishers, or distant relations.
And what about very old friends? Steve Silver, thank you so much for the resubs. Steve for the 11 months, almost a year. And Silver for 31 months. Let's go! Thank you so much. Like I said, huge thank you for the support. Any bit of financial help really helps these days. So thank you so much. But there's definitely more than 20. Yeah. Can we do something to tweak the numbers a little bit to make it better? By better, I mean closer to 10 billion. Should we make something bigger or smaller to get like closer to a more proper answer? 5 stream streak, let's go. After this, I'll stop interrupting. Never. No, we won't find you the votes. So we can obviously make either the top stuff bigger or the bottom stuff smaller. That will give us a bigger answer of n in the end. So what we could do is we could say that the speed is slower. What if we change the speed of capillary. Did we actually Google this? Speed of blood in capillary. 0.3 to 1 millimeter per second. That's way too fast, no?
No, thank you. We don't want any more visitors, well-wishers, or distant relations.
And what about very old friends? What about very old friends indeed? Thank you so much, Lizard, for 60 months. Oh my god. Holy smokes. 60 months. Quick maths, chat. Is that 5 multiplied by 12 is equal to 60? Are you here 5 years? You're here longer than 5 years. Holy smokes. Thank you so much for the support. You're very, very kind. Checks out. Listen, I have to confirm the divisions. My mental maths is really not on the money. We did edit the problems a little bit. It could, yeah, you're right, Daniel. Let me actually see what the answer is. The real answer with the original problem. I can't do 2 plus 2, sorry. Let me turn this way. I was about to put in my password. Ooh. Oh! They even got a lower answer than us. They got 7 billion. They got 7 billion. So... by 10. That's 5 by 10 to the minus 4 meter. Is that half a millimeter? Oh, that is closer. Nice. So if we change it to we change it to 3 millimeters per second, we get closer to the answer. Yes, it is half a millimeter. So let's change that speed to 3 and we'll actually get closer to 10 billion then. I am altering my answers to get a more realistic answer, but it's nice. It'll be a nice problem for the kids. I say kids, again, I mean, I teach adults, but, you know, for the kids. For the kids, chat. So, here is this. Then, answer, according to Daniel, is 13.7. Right. Maybe 0.4 is enough of a difference to get you to 10. Nah, it's fine. It's fine. All good. Close enough. We got close enough. Oh, we started a hype train accidentally. Whoops.
Choo choo. Motherfucking choo choo.
That's a fair point, Tarek. I did look up, now this is Google AI, so let's be clear that this might not be true. It did say that the capillary, it was 10 to 40 billion capillaries in the body. It depends on the definition of a capillary. So it's okay if we go over 10, I think. Am I right in reading? I feel like we need more doctors in the chat. Not me kind of doctors, like doctors in the chat. MDs to confirm and deny all the rumors we're spreading. And our blood flows so fast. And if you have... So if our aorta pumps 40 centimeters per second of blood. Okay, I'm going to do some maths here. Just interesting maths. We're just doing maths for fun. I bet, yeah, it depends on the size of the person. Yeah, exactly. So what I'm going to do is I'm going to bring you down. Just so you can see some of the stuff I'll be doing. Sorry. Hope no one gets too nauseous there. Ideally, I'd put the camera upside down, but I'm too lazy. But I'm just going to do some quick maths. So, if our aorta, let's take it as a cylinder, right? Okay. And it has a radius of 1.5 centimeters. Okay. Can you see that? You guys can see that? Okay. So, sorry, this is upside down for you guys. I'm too lazy to flip my camera for this quick thing. So if the radius of our aorta is 1.5 centimeters and it pumps blood at a rate of 40 centimeters per second, how much volume do we lose in 1 second? So, or how much pumping do we do in 1 second? So the length is 40 centimeters in this case. That's how much it completes in 1 second. Radius is 1.5. So the formula for the volume of a cylinder is pi r squared h. Pi, the radius is 0.015, all to be squared, times 40 centimeters, which is 0.4 in meters. Let's grab our calculators for that. Why not do it on the whiteboard? That's a great... The thing is, if I do things on a whiteboard, it takes so much time. I'm very slow carrying on the whiteboard. But you're absolutely right. We should have just done this on the whiteboard. Unfortunately for you, not very smart. Like I said, I just want to do this calculation for myself. 8.3 by 10 to the minus 4 meters cubed. That's a lot of blood. How many liters does a human body have, chat? I think it's 6 liters. How many liters of blood does a human have? 4.5 to 5.5 liters. We'll say 5 liters. Jesus, when you give blood, you give half a pint. Sorry, you give a pint. You give half a liter. Shit. Oh my god. Sorry. So, we'll say human body has 5 liters. 5 liters is 5,000 centimeters cubed, which is 5 by 10 to the minus 4 meters cubed. No, 5 by 10 to the minus 3 meters cubed. Check my dimensions. So 5 by 10 to the minus 3 divided by 2.83 by 10 to the minus 4. A 1,000 liters is a cubic. Yes, that's correct. Divided by 2.83 by 10 to the power of 4. 17.7 seconds. So, did I do this right? Am I crazy? Our heart pumps the volume of our whole body in 17.5 seconds. Isn't that insane? Imagine a rupture in your heart. That is crazy. Holy smokes. Now, this isn't a mathematical problem. This is just, sorry, it is a mathematical problem. But I just, made up this problem as we're doing this kind of along the way. Just based on the figures we got. Let's Google this to confirm it. How long does it take to pump our whole blood? That's a bit of a trick question though, because there's weirdness there we have to be careful of, because not all the blood is going to be at the same rate in all the capillaries. It's a bit different. I'm not sure if I'm wording this correctly. It takes about 1 minute for your heart to pump a volume of blood equal to your entire body's blood supply through the aorta at rest. So that I think is a little bit different. So let me again explain. Remember that the capillaries are very slow. 5 by 10 to the minus 4 meters per second or something like that. It's very, very slow to pump blood. So obviously in those capillaries, it takes a while, let's say down at our legs and stuff, but further from the heart. It takes a while for them to come back up. So I think that value says that it takes 60 seconds for all the blood in our body to complete one cycle. So if you grab a single cell, worst case scenario, it will have repumped in 1 minute. Is that a fair statement that I'm making, chat? Ooh, sorry. Evolution has given us a built-in insanity check. How long can you hold your breath? Oh, that's interesting. What was the liters per second number we found? So what I did was, I know at what speed blood flows through the aorta. It's 40 centimeters per second. I know that the radius of our aorta is 1.5. And so I used the volume of a cylinder to calculate how much volume we lose per second. And I got 2.83 by 10 to the minus 4 meters cubed. Now, we have about 5 liters of blood in us. This is a bit extreme number, actually. I took the largest possible aorta size, which is 1.5, but then I took the average volume of blood. Realistically, I should have done the big maximums all across the board, because generally, the bigger you are as a human being, the bigger your aorta is going to be, and the more volume of blood you're going to have. Those things are proportional. So I do have a few caveats here. Sorry, I'll hold it up. I'll hold up my solution. You guys can have a look. Sorry, I actually don't see the chat. So I found that it takes 17.7 seconds for your aorta to pump your whole volume of blood. But again, there's a few caveats. I took the maximum size aorta, but the average volume of blood. So little things like that, I have to be careful. If you're going to take averages, you have to stick to averages. If you're going to take maximums or minimums, you have to do the same. The blood volume is 70 mils per kilogram body weight in adult males, 60 mils in adult females, children. Oh, kids have more blood in them. I don't know why I was thinking like a vampire there. Well, that's an interesting stat. If there's any vampires in the chat, there's more ratio of blood per mass in kids than there is in anyone else. Just saying. Look, it's just science. Don't look at me like that, chat. It's just science. And in fact, men on average have more mils per kilogram of blood. So, and for some reason, the victim in all horror vampire movies are always women. Scientifically, vampires should be going after, number one, children, number two, men, and last but not least, they should be going after women. The women should be less of their priority because of their ratio of blood per. Ooh, this is a fun calculation. Vampires suck blood. Here we go. Oh, okay, we're gonna do this on the board. Okay, I have an idea.
Precious.
Hey, thank you so much for the Prime. Really, really appreciate it. Thank you so much. So therefore, 70 minutes would be the minimum time for all to be cyclable, one maximum an hour. No, so 17.7 seconds would be if the aorta was existing by itself with no other human parts, it would take 17 seconds for the aorta to put all the blood out of your body. It takes 1 minute because some of your blood goes all the way down to the bottom, all the way back up. And because of the long distance it takes to get there and back up, it takes 1 minute before the longest point of your body comes back to you. So that's why it takes versus the calculation made. There we go, random logic. That's exactly what I want to see. Sorry, I need my phone. I need to take a picture of this because I want to do this problem on like a YouTube video on this. Actually, all of this is really fun. The physics of vampires. I had this idea of just doing like 4 or 5 different random physics problems, but we're stuck on blood. I really like these blood problems. I'm coming back. I'm gonna take a quick. Charge my phone. Tariq, those numbers. What was it? 65 mil per kilogram for a woman. 70 mil per kilogram for a man. And 70 to 75 mil per kilogram for a child. Is that correct? Oh my god, too shy. Oh! As a first-time chatter. Okay, I'm back. Yeah, where was I? 1 year old and over. Okay. Yeah, what are babies? Maybe that's dark again. Yeah, maybe there is higher circulation in pregnant women. Perhaps. Perhaps. Have to have a week about it. Anyways, so another science that I want to look into. Halloween videos. Oh, I should do this for Halloween. A very good Halloween special. So, we're going to need a few numbers. We know that a human has about 5 liters of blood. Five by 10 to the minus 3 meters cubed. Okay. So, Tofu, what's your dissertation on vampires? This went to... I know, Turing. Hi, by the way. This has evolved beyond what I thought the stream was going to be about. I'm sorry, I got distracted. So let's think about the chews in a vampire's teeth. How big are his chews? How big do you... They have to be tiny, no? I would say they have to be pretty tiny. There's no way they could be that big. I'm checking the size of fangs. Yeah. That's true, Soul Guardian. But I wonder if a woman who's pregnant produces more blood? Or like... Oh no, that's... Her blood concentration or like what's in the blood could change. Again, I'm no biologist, no medical scientist, so we're just kind of exploring ideas. Yeah, exactly, Agisec. That's what we're thinking. So we're thinking that the vampire sucks the blood like straw. We need a medical doctor. We need so much more in this. I always use mine to just pierce the skin and then drink through. Exactly. We have to also keep monitoring that there's double the suck, because there's 2 fangs, obviously. Oh no, I'm late for vampire. Yeah, sorry, chat. I know we were going to do the physics of biology, but we got distracted. This is really interesting. So, okay, medical people. What main artery is in our neck? Let's have look. Main artery in the side of the neck. We need numbers. Main artery. Common carotid artery. Okay. Oh, my Google search is so fucked. Common carotid radius. There you go. Yeah, that's right, Daniel. Yep. Everybody's Googling so many weird things. So it is 2.5 to 3.2 millimeters. We'll say 3 millimeters. Oh, shit. Okay. Carotid. How do I say? Carotid. Oh, it's carotid. Fuck. I know this artery. I was thinking about a different word. I got me. Okay, that's the radius. Okay, what's the flow rate? Although, does that affect it? Let's do it this weirdly. Let's pretend that the fan goes directly. Yeah, okay, here we go. I have memes, I have knowledge. So, speed of blood. Just to make this quite sciencey, you know? Speed of eroded artery. Oh, 30 to 40 centimeters. It's pretty fast. It's almost as fast as... Bad. So we'll get an average, 35 centimeters. Now, let's think about the vampires. So, chat, do not Google this. Average sucking speed through straw. It's dependent on the size of the thing, though. Okay. Oh, we can do double maths. Oh, okay. So, if we want to determine how fast the vampire... No, we don't need to know it. We don't. That's actually fine. It's actually fine. We don't need to know the average sucking speed of the straw. That's something we can actually calculate. We can determine the average sucking speed of a vampire as long as we can determine the radius of the vampire's tooth. So, yeah. So we know what the flow speed is. So then, but that's flow. Suck and flow are two different things, but we're going to make that assumption that the vampire is, yeah, because where is the sucking connected in the tooth? It's kind of weird. So in this case, what we're doing is, this is the assumption. When vampires drain human blood, what they actually do is they directly pierce the carotid artery in the neck, okay? And they insert their fangs in a way that directly connects to that artery. So what they do is they insert it so perfectly that it's quite literally like, this is the artery, then this is now the new fang that's connected in there. So in that case, you have a different area here, different velocity. You have a different area here and a different velocity. We're going to find the area here, and we know the velocity here. We know the area here. We want to determine the velocity that gets sucked by the vampire. Oh, we're so back. Hi, King Egg. Welcome in. Welcome in, Pre. Exactly. So what we're doing is the vampire doesn't actually suck, but rather the velocity of the blood pumping flows into the vampire's tooth. That's what we're doing. This is the assumption that we're trying to make. This makes the fang situation a bit weird, chat. Here's the problem. A vampire has two fangs, but in this case we only have one fang. Do you know what I mean? Like a Capri Sun, exactly. So imagine a straw of Capri Sun and you squeeze the Capri Sun and, you know, it flows right into your mouth. You're not even sucking on the straw of the Capri Sun, goes straight in. It's to do with... exactly. Half the floor of your aorta per one teeth. What if we look at... what if a vampire pierces the neck at two arteries? These of human... let's have a look. Is there like two arteries? What about if it pierces an artery in a vein? Is there any lore in vampires where it's bad for them to suck vein out? Maybe disease. Yeah, because there is a lot of lore with vampires where they can't drink the blood of a dead human, right? And there's all these kind of things. So I wonder, do they have to drink out of the artery, or can they simultaneously pierce the artery and the vein, then double suck that way? I understand that a lot of people are talking about the vampires sucking through the fangs and stuff like that. We're going to assume that the fangs are straws. We're working on this basis. Or blood where the person has been dead, the blood doesn't flow. Maybe, King Egg, maybe. Okay, so if we look at the human thing, I'll show you what I'm looking at. Just to show you what we're looking at here. Like, there is that red one is the vein, and the blue one is... sorry, the blue one is the vein, I think. and the red one is the artery. So, I mean, you can see how although I just need like a realistic two arteries or two veins that the vampire sucks out of. What about a jugular vein? Would a jugular vein be appropriate? Wonder. Oh, that's a very interesting title. Hi, Kim. We could look into how vampire bats... Oh, yeah! How do vampire bats do it? Wait, aren't vampire bats fruit bats? Isn't that the misnomer one? If you're pulling that much volume out of the artery, pretty soon there will be much less flow. Oh, that's right. That is confusing. Okay, let's go for two veins, two arteries then. Is there two arteries? Obviously, we're going to go for the common carotid one. Is there another artery we can go for? Is there another? How much can they suck without a victim passing out? And do a lot of calculations. Although when you donate blood, you give half a liter. Did you know that? And I'm a small person. So I don't find this fair. I have less than 4.5 liters of blood in me, I think. While an average person has at least usually a liter over me. So how is it fair that I still, when I donate blood, have to give half a liter? I feel the injustice there. Anyways. I don't think with it, but Shrew, you can adjust the canine teeth. So let's say the veins are really close to one another. If you just angle yourself more, you can kind of separate in that way. I donated on Tuesday. It doesn't look like a large amount when you're done. No? Oh man, it looks like a lot. That's a lot of blood. So I don't think the distance is the issue. Oh, well, the distance is an issue if the two veins are too far apart. But if the veins are too close to one another, that's not a problem. A vampire can angle his teeth and bite, which I think they tend to do. Either the carotid on the other side or all the way around back. Ooh. Is there maybe a small artery? Okay. Let's see if there's something. It's so weird if the vampire only sucks out of one tooth. I want it sucking out of two, you know? Yeah, why don't vampires just bite into the chest? They prey on seduce them.
That still only counts as one.
Oh, making sense now. We figured it out. So I'm looking for arteries on neck. It's okay if it's a small one. Really? It does separate into two, like up here. Here, another one. You should expect there to be a bite mark from the other teeth, and the blood likely flows from the teeth high velocity and the volume, so the teeth are just keeping open. Alright, let me read that again. You should expect there to be bite marks from the other teeth, and the blood likely just flows around the teeth because of the high velocity and the volume, so the teeth are just keeping... Oh, right, according to real... Okay, that's okay, that's okay. We're gonna still assume that the teeth are straws. I know that that's the incorrect assumption, and a lot of people have said that that's not the way vampires work. Supposedly. But we're gonna assume the teeth are straws in the case for this problem. Just because it's a nice problem working with the continuity equation. No worries, Tari. Thank you so much. Assume a spherical vampire. I'm going to state another assumption. I'm going to pretend that the first tooth that pierces, so here's our vein, our artery, goes in. The second one doesn't do much sucking, but rather is a backup in case there's any leak. This guy is simply a backup. But it's this tooth that does the sucking over time. So as long as this is working fine, we're all good. But this is a backup in case, you know, a vampire breaks its tooth, or
And they call
has a
it a
toothache,
mine.
or, you know,
A mine!
we need to consider all these things. Very important things to consider. King Egg, thank you so much for the resub. Really, really appreciate it. 15 months, let's go. Hi, Sly. Thank you so much for all the resubs, Rats. Really appreciate it. Vampires drink from veins. Really? I'm assuming they're drinking from the artery because so fast. Where do they go for a checkup? Yeah, maybe a vet. If vampires have toothache, they go to a dentist for normal all the other teeth. But if it's specifically their canines, they go to a vet. No, because in this case, Daniel, what I'm saying is, it's our vein. Then suddenly the tooth pierces it. The different, you know, I'm assuming that all the blood flow from the artery goes straight into the first tooth. That's my assumption. I'm making a lot of assumptions here. Yeah, don't judge me. This is just one of those assumptions we're making. It's fine. Nobody panic. So that's why the second tooth is used as backup. But if it were a walrus, the vampire, we could never suspect a thing. Okay, so with that being said, there's one of two things that we can make an assumption. Number one, we can assume the size of or the radius of a vampire fang sucking straw. Number two, the speed at which he sucks the blood. You know what, caveman? I feel like I've made so many absurd assumptions that that is not even a concern. I think we have bigger fish to fry before we even get to that point. Okay, let's see how thick. Let's say the vampire tooth straw is 1 millimeter in diameter. I feel like that's reasonable. That's not that big. What do we think? Wouldn't and the artery just kill the person? I don't know. It depends. If it's like a very thin needle and you don't, you know, rupture anything, get away with it. The big assumption of. Is this biology 101? We were meant to do biology. I got distracted by this vampire problem, which now has inspired a whole different YouTube video that I want. I was going to do like 5 little fun biology problems, but I got distracted about the blood stuff that I wanted to do video. The equation, fluid mechanics, and apply it to vampires. It's not sniping. I'm trying to think of the word. What was that issue we ran into when we were our robotics project? Creep scoping. There we go. We're creep scoping our. Okay, so what we can do is we can calculate the velocity of blood being sucked in by the vampire. Once we know its velocity, we'll know how much it sucks blood per unit time. And so, assuming that it continues to suck, well, here's the problem. As the human quickly loses the pressure and the velocity of the speed of the pumping of the blood in the body because there's less blood, person will die. So what we might measure is how long will it take for a person to die? So how much blood does an average person have to lose before they die? Hi Leo, welcome in. Hi, welcome in Ryan. We're coming up with vampire sucking problems. Google searches are oh my god, the Google search is going to be so bad. Okay, whatever, I'm taking the risk. How much blood do you need to lose to guarantee death? That sounds so bad. No, I need to Google this carefully. How much blood loss is fatal? There we go. That sounds bad. Garda, Irish FBI, whatever our detectives is, we're doing this for science. We're trying to determine blood flow in vampire. Listen, don't judge me, okay? Okay, so there's 4 classes of blood loss apparently. So minor blood loss 15%, moderate 30%, severe 30 to 40, critical is anything above 40%. So, my god, it tells me at the end, please call an emergency. I feel like you've lost a lot of blood. Oh Jesus, oh Jesus. I swear to god, there'll be a knock on my door today. Oh, a knock on my door. Okay. So what's 40% of 5? Shouldn't need a calculator for that. That's 2 liters, right? 2 liters. So if we lose 2 liters, it's critical. So we're going to assume that the pressure and the flow rate of the aorta is not going to change until we lose 2 liters. So we're going to measure how long it takes for a vampire to suck enough blood out of us to kill us. Allowed on you here. Bagged. I feel like I'm not doing anything that dodgy. Kids love this stuff, right? This will be great kids education, no? How to dispose of a body. I know, my Google search is going to get worse. It's fine, chat. It'll be fine. Is that a realistic assumption? Okay. Okay. Let's clean up this board because I made a huge mess. First step, we're going to use the continuity. Is U1A1 to V. We're going to determine the speed at which the vampire sucks blood. That's the first step. Once we know the speed, we can... How long is a vampire tooth? Say 3 centimeters generously. I know, real men grow beards, welcome in. I should have saved this for Halloween. I just got derailed. I just got really interested in this and I didn't stop. This happens sometimes. Very normal for the stream. So we'll say that the tooth length is about 3 centimeters. Oh no. I don't even need that. Sorry. So you need to just determine the volume, which is pi r squared h per second. Divide that by 2 liters. And then determine basically how long it takes for a vampire to suck your blood before you die. With the assumption that the vampire doesn't actually suck blood. It pierces with these fangs. It has the little hole. It does a very, very precise injection. And what's happening is the blood is quite literally flowing in there. Because I don't know how the tooth is connected to the sucking system of a vampire. We'd have to dissect a vampire to know for sure. And again, apparently that's not how anyway. But I'm starving. I'm going to go grab a quick snack. And I'm going to feed Bambi. So if you guys haven't seen the pinned message, my poor rabbit, very, very sick at the moment. And I have to give her medicine. So I'm going to take about a 10-minute break. Some medicine. Actually, not even that long. Because I'm not giving her medicine. I'm just syringe feeding. We're just going to give her a bit of food. Get her tummy going. Come back. We'll continue. I'm going to give you a moment to actually calculate this problem. What I'm trying to determine is how long does it take for a vampire to... We're assuming 1 straw of the tooth is actually functioning at any given moment. So why is that, Tofu? Well, when a vampire bites a human being, it sneaks up behind them, right? And it has only a moment to act. Even though a vampire is very precise and accurate, it can miss. So in reality, what it wants to do, it wants to get that vein, that tooth, perfectly closed in contact with the aorta, but maybe it can miss. And so has a 50-50 chance of hitting, or you double its probability of hitting the correct vein with the second tooth. So it's only 1 tooth functioning at any given moment. These are all the caveats I'm giving you to solve this. All right, I'll be right back. I'll see you guys in a few. Are these sparkly vampires the best vampires? I'm back. Guess who's back? Back again. Oh, I'm terrified. Starving. I'm just gonna have a quick snack. That's nice thinking, real men. Yes. This is better than my hamster power plant. Oh yeah, did you try and calculate how many hamsters it takes to power things? I tried to get some information on that. I was also interested. How many rats does it take to power certain things? But it seemed really impossible to get proper numbers. Turns out a lot of people haven't released a lot of statistics on rat power. Maybe that's a whole PhD I could fund. Hi, Chaplaments. Welcome in. Finished. Well, no, I just started, but very tasty crisp. Oh. Didn't realize how hungry I was. Yes, yeah, I only ate a bit of cottage cheese and jam today. That's not a very filling breakfast, I would say. Okay. Iced tea. Should be careful about drinking iced tea, actually. It makes me want to pee. Although everything makes you want to pee more. Or coffee. I just realized you guys might not have this bag of chips and potatoes in your countries. Your respective places. You guys have these kind of crisps? The camera, focus. Focus! Focus, camera! Damn it. Mmm. You like potato puffs? Right. Nice. Let's do some maths. Yes, there's a little society, a local society beside us that is going to do some, is organizing a sightseeing on the 12th. So I think we're going to go drive out there. There's a viewpoint that we're going to go drive out to. That's the plan anyway. I've seen taters on rare occasions and nice. We tend to have walkers here quite often, but do you know where we always have walkers? In Subway. Subway is where they serve them here. Okay, so let's actually do this calculation. Some calculations. Welcome back, Tarek. Hi, Johnny. Welcome in. No, I'm not the... It's not just Twitch chats. I read YouTube as well. Daniel and I have been having a great time the whole time. Okay, so what we're going to do is... going to be the velocity of the artery. Area of the artery is equal to the velocity of the vampire divided by area. Tooth. Velocity of artery. Sorry. My mic might not have been picking me up. Apologies. Loaded is millimeters. That's 3 millimeters, yeah. High, and the velocity is, I think it's 0.35 meters per second. There's no way it's 35 meters per second. 0.35 second. Okay. Then we're going to divide it by the area of the vampire tooth, fang, which is 0.5 by 10 to the minus 3, all to be squared times pi. The pi's cancel. No pi for anyone. Yeah, the light ring is obscure in the middle of the board. There's not too much I can do, because otherwise there really is very bad lighting.
I still only counts as one.
Actually, it is 35 centimeters per second. So, no, 35 centimeters is 0.35 meters. It's divided by 100. Centi is 100. All good. I think it's okay. Let me see if I can maybe angle the board a bit this way. It's a bit weird. Oh. Close enough for now. No, it's okay. It's good to check your mental maths, 100 and 1,000. It's good to keep each other sane. Okay, so let's do that all in our calculator. Let's grab it. 3 by 10 to the power of minus 3. All to be squared. Multiply by 0.35. And then all divided by 0.5 by 10 to the minus 3 to be squared. We get an answer of 12. Fuck off. Sorry. 12 meters per second! That's fast. What's the flow rate of a needle? Anyone have an average flow rate of a needle? My Google search is so dodge. I'm so getting arrested. 13 milliliter. No, that's volume. Average speed. Okay, I need. All right. I don't want to do the maths right now. Yeah, 100 millimeters per second or 500 millimeters per second. That's no way. We're calculating the flow, the speed of the blood in the tooth of the vampire going into the vampire. That's what that means. 12 meters second. The smaller the needle, the faster it's going to flow, yeah. That's fast. That's really, really fast. The bird that drinks blood by nature. Bird? No, I don't know about the bird. Yes, we are. True. That is so fast. I mean, did anyone check the maths? Did anyone else also get 12.6? I should this way. Ooh. Better. Other light hits it. Can't win. You did as well. Okay. A few people. Exactly real. That's what we're assuming. We're assuming the teeth are straws. That's the assumption we're making. Okay, so listen, that's fast as heck. All right. So let's determine how much volume it sucks per second then. So the volume of a cylinder, because that's basically what a straw is, it's a cylinder, is pi r squared h. That's pi times the radius. To be squared times 12. Oh, sorry. Times, yeah, 12.6. That's the length it covers in 1 second. So we're going to find out how much blood flows per second in that case. And I got almost 10 by 10 to the minus 6 per second. Almost 10 by 10 to the minus 6. We have it. You need to lose about 2 liters of blood. If you have a 5-liter average person and you need to lose 2 liters of blood before you die, before it's critical, how long will it take for you to die? Well, 2 liters is 2 by 10 to the minus 3 cubed, divided by 10 by 10 to the minus 6 meters cubed per second. What we're going to do is we're going to find out how many seconds it takes for you to get into critical condition as the vampire is sucking your blood, with a lot of assumptions. I should have done this in my head. I don't know why I didn't. I'm clearly too hungry to think. Don't judge me. Yeah, 300 seconds is 5 minutes. So the vampire needs to suck you for about 3 minutes before it kills you. So in movies, when they show a vampire sucking you, it shows like only a couple of seconds before you die. Now, when we say Vampire Diaries got it wrong and all of that, we're assuming that the vampire is straws. The teeth are straws. And we made a whole bunch of assumptions. But yeah, there's a lot of interesting things to think about it. Maybe they have venom too, that is true. What's the volume of a stomach? That's a great question. Okay, we'll go further. Volume of a stomach. Hey Tofu, what was that channel you said is OG for electrical circuit boards? Oh, I think it's called circuit board. Double check them. circuit bread? They're like circuit bread or something. Yes, circuit bread. That's the one I really like. They're really good for electronics. I haven't watched them in a while, but they're pretty good. I'll post the link here for you if you want. We're using pure blood pressure, yes. Well, not even blood pressure, blood velocity due to blood pressure. I've always wondered, is the Ising model at all? I don't know the Ising model. Sorry, dummy. Also, could victims pass out after, say, 30 seconds of blood sucking? That's true. That's true. How long does it take for you to pass out from blood? Oh no. How much blood loss to pass out? Again, if anyone ever finds me on the internet, or sorry, if the Garda find me, questioning me, this is science, please. I have evidence that this is science. No, it's not giving me a number. It's okay, here we go. AI was telling me stop searching this. So about 50% blood loss is actually what we needed. So technically it's longer, about 4 minutes before, because about 50% is guaranteed death. But into hemorrhagic shock, you need to lose 20%, so 1 liter, so half that time. So in about a minute and a half, you will pass out. You will go into shock. So a minute and a bit. We'll say a minute. It will take 1 minute before you go into shock and die. Vampire bite. They didn't believe me. I will never. We're not burying any bodies, I promise. Blood donation does take a while, but that's like a pint. Yeah, it's half a liter. When you donate blood, that sounds like a lot of blood. I feel like I would be more tempted to donate blood if it wasn't so much. Because again, when we talk about percentage blood, that's a huge, like, I'm on the smaller side of humans. So I would be about 4.5 liters. And if you have to give 0.5, right? Let me just see. Because at 15%, it's 11%. But at 15%, it's normal to be faint and dizzy due to blood loss. 15%. And I donate, in this case, about 12% of my blood. That's cutting it pretty close. Answer with the question, why do you ask? That's true, real man. Yeah. When vampire victims become victims, they don't fight back against the vampire. Oh, stomach question. How much volume does a human stomach? An average adult human stomach holds about 75 to 750 milliliters when empty or relaxed, but it can stretch comfortably to about hold up to 1.5 liters of drink and expand to a maximum capacity of 2 to 4 liters under extreme. So like the poor vampire stomach, if he drinks 2 liters of human blood in this case, they actually like, that's really maximum for them. Apparently the UK has a minimum weight to give blood. Oh! Does it? minimum weight to give blood. I have gained weight, a little bit of weight. I think I might be over 50 kilos now. Yeah, in Ireland, you have to be over 50 kilos. I think I might be over 50 now. Yeah, maybe it is something about the vamp. We were talking about it. How much blood does a human body produce per day, though? I suppose you have to always replace your blood. The question is, at what rate can the blood be replaced? But I wonder if it's a ratio thing. No? Where... if you're missing 30% of your blood, your body produces X amount. And then if you're missing 20% of your blood, your body produces X amount. It's not a constant, but a ratio. And I don't know if it's linear or logarithmic. It'll be interesting to look into the biology of that, actually. Euphoric from the bite. That's true. Sometimes you see that in movies, that when the vampire sucks the blood, usually of a female victim, she kind of looks like she's, sorry to be crude, having an orgasm. So maybe that euphoric thing, true. Yeah, the replacement rate, because in Buffy the Vampire Slayer, there was actually an episode about this, where there's a... sorry, spoilers. 90s. But in Buffy the Vampire Slayer, she had a boyfriend named... not Riddick. Oh my god. I only watched that show times. It was the worst boyfriend she had after Angel. No, it's after Angel. Not Adam. Adam is the villain. No, before Spike. And Spike was never her boyfriend, technically. After Angel, before Spike. It was in college. The college season. He was a military guy. Ryan. Rico. Riddick. Why am I thinking about oars? It's bothering me. Riley! There we go. Thank you, my brain. Anyways, Riley. Their big breakup happened in Buffy the Vampire Slayer because he went into a den where there are a whole bunch of vampires that drain blood for money. Like, he goes in to pay for a vampire to suck blood. I guess for that euphoric kick, but they suck it out of an arm slowly so that they don't kill you. So there is that kind of thing. Now, if you wanted to keep a pet human, how much blood does a human replenish? Do we have a value? A human body constantly generates and recycles blood, producing 2 million new red blood cells. After losing a standard pint of blood, the body replaces the lost fluids within 48 hours, while the red blood cells takes 4 to 6 weeks to fully replenish. Okay. Let's take it on the more critical side. Let's say the vampire has a pint of blood, about 500 mils, per month. Okay, how much blood? How much blood does a vampire need to live? A vampire typically needs anywhere between 1 pint per week to 2 to 3 pints per day. Okay, so in low maintenance fiction, it's 1 pint per week, but in like calorie calculated in human calorie needs, it's about 2 to 3 liters per day. So assuming vampires need calories, it's about 2 a day. So in that case, we'll say 2.5, and there's about 30 months in a month. Sorry, 30 days in a month. So you would need about 150 human slaves on the safe side. That's a lot of human slaves to suck blood from. Like, and you have to feed them and you have to maintain them. 150 people is a village, lads. I'm not interested in that, Sebastian. Sorry. Can also vary widely based on lore. For example, the vampire powers are powered by blood. Power depends on how you use. That's true. Depends what vampire sucks your blood. Dracula, he could turn into. Are we assuming that vampires don't eat burgers to get their calories? Yeah, so in some lore, they can eat food, they just don't get anything out of it. So they fake eating. They can get away with fake eating. In other lore, food can be poisonous to them. A very rare burger. How does that work? In many vampire lore, they can't drink the blood from a dead human. Like, that's dangerous. That kills them. But if you have a steak that's rare and there's some blood in it, do they die from that blood? Is a rare steak going to kill a vampire? Hmm. There is no blood in steak. Is there no blood at all? I would assume there's some, like very little amount, but some. Found normal early. Go on, shoot, Gagny. We probably should move on from this topic. We got really involved with vampires. That was not meant to be the topic of today's stream, but we got really distracted with vampires today. Would the presence of garlic as a natural anticoagulant affect the blood flow? uh what is the difference? Water moving phases and steel. Oh, I can't answer that at the moment. I have not covered. I did years and years and years ago. I'm not revised on the steel part. I'm so sorry. I need to do more research in that. Hey, Grumpy. Welcome in. Given that there's 8.3 billion people, there's about 55 million vampires at a requirement of 150 per vampire, or somewhere between Colombia. Dr. Ramsland's book, The Science of Vampires. That might be fun, yeah. That would be interesting. My nose is getting phlegmy, clogged. This stuff is really good. I have a spray that really clears up the nose when it's really bad, but it's so good that it dries the nose so much that you're so sensitive and you sneeze a lot. Very, very sensitive. So I do prefer this if you can get away with it. Much milder. Problem is you can taste it in your throat though. Brats, I want to say a huge thank you for humoring my distraction. I don't know why I got so distracted with it. That was a lot of fun. How did this even happen? We just looked up one blood thing. It might be interesting to see if we can do another blood problem. Just because I kind of want to do another one. Hopefully we won't get too distracted though. But yeah. Oh, I should take a photo of this in case I want. And delete your search history. Look, the guards will always find me if they do. So when will you play Vampire, the Masquerade Bloodlines? I think we'll have to put up with just Anna playing. What's the biggest distinction between chemistry and material science? Great question. Guess it depends in which field of material science, but in my experience, material science is all just physics. So the question is, what's the difference between physics and chemistry? Although you might talk about bonds and so on and so forth. Chemistry has very, very specific models for niche stories and niche situations. While material science is a little bit more broad, but also cross-applicable. That makes sense. It covers a lot more broader things, and you can get very accurate and specific with that. Everything is just physics, that is true. Because someone blessed the rain. I bless the rains down in Africa. Cathodic protection techniques count as material science? Oh, no idea. Okay, let's go find one more blood problem or one more biology problem. Now, there's really broad biology problems like knee joints and lubricants and stuff like that. Because I think we're all getting to that age, chat, where we need to be concerned about the lubricant in our knees. Maybe I'm insulting some of you. Maybe a lot of you don't want to admit the truth in the statement, but it might be a concern for many of us. It's just electrical blood. Okay. Look at another problem if we find the word blood. Okay, applications of Bernoulli's principle, blood flow. The lack of blood in the brain. Okay, let's have a look. In medicine, one of the many applications of Bernoulli's principle is to explain TIA, transient ischemic attack, meaning a temporary lack of blood supply in the brain. A person suffering from TIA, so lack of, blood in the brain, that's a very popular one. Two things can happen. Number one, too much blood in the brain, that's also a bad thing. And too little blood in the brain, that's also a bad thing. Because if there's no blood in the brain, you're not getting oxygen. Very, very important. Blood normally follows up. I got interrupted.
No, thank you. We don't want any more visitors, well-wishers, or distant relations.
And
But what about very old friends? Thank you, Bog. Really, really appreciate that. Thank you so much for tier 3 at 31 months. Thank you so much. I hope you're keeping well, Bog. Welcome in, welcome in. Thank you so much for the tier 3 sub. Really appreciate the support. Now more than ever, we do appreciate the finances. We were just doing some physics of blood, so you're coming in a perfect moment. Blood normally flows up to the brain and back of the head, up to the brain at the back of the head via two vertebral arteries, one going up on each side of the neck, which meet in a form of a basilar artery just below the brain. So here at the back. Right, you see that noggin, that little dent in the back of your head? Each vertebral artery connects to the subclavian artery as shown before the blood passes to the arms. When an arm is exercised vigorously, blood flow increases to meet the needs of the arm's muscles. The subclavian artery on one side of the blood is partially blocked, however, and then the arteries harden. The blood velocity will have to be higher on the side supply that that side to supply the needed blood. So this is about the continuity equation that we covered. The increased blood velocity past the opening, the vertebral artery, results in lower pressure, i.e. Bernoulli's principle. Thus, blood rising in the vertebral artery on the good side at a normal pressure can be diverted down into the other artery because of the low blood pressure on one side, instead of passing upward to the brain. Hence, the blood supply to the brain is reduced. So basically what it's saying, I know I kept mispronouncing, but when blood is flowing up here, it kind of joins back up here and it goes back into your arms here as well. What's happening is, if the blood pressure differs much, what happens is the blood flow is going to favor and bypass the straight to the other arm instead of going to the back of your head. I don't know why I'm hitting the back of my head, but that is because of Bernoulli's principle, because of pressure differences. There is a concern there to be mindful of. So clearly, where I'm going with this, exercising is bad for the brain. Why is there 9 marbles in your Newton's cradle? How many marbles am I meant to have? Hi, Kat. Welcome in. Today's birthday is Paul Dirac. Oh, and Penrose. Tomorrow is Avogadro's as well. Some awesome August babies. The first one is the sun. I know it doesn't look like much. First one is the sun. Woo. There's capillary action, pumps, and the heart. Ooh, there's some heart pumps. That's just an explanation, but that's really, really good. I like this explanation for the heart pump. You can make like a mechanical heart pump because of it. How does it pump blood? He did. He predicted the existence of so many things, basically all antimatter. Would gas planets even have elastic clips? Happy birthday, Kat. Celebrating of Paul Dirac. Let's go. That's why we raise the legs when we need to increase blood flow to the head and torso. There we go. There we go. just looking at a bit more problems. When there is a paragraph about blood, there's a lot of word blood. I'm still doing, word searches at the moment. Oh, the Doppler effect using blood? Oh, cool. For example, ultrasonic waves reflected from red blood cells can be used to determine the velocity of blood flow. Similarly, this technique can be used to detect the movement of the chest of a young fetus and to monitor the heartbeat. I didn't realize that the Doppler effect specifically was used for that. Did you guys know that? That's cool. The Doppler flow meter. I finally have an antimatter example too. Yes, PET scans. It's so fascinating because so many people I talk to, okay, like, I don't know, I take the taxi quite often. So many taxi drivers, when they ask, oh, what do you do? And I say, oh, I'm a physicist. I swear, it must be some weird conspiracy theory thing. Because so many conspiracy theorists, they're my like most real life example of people who don't believe in physics. Because they'll say something like, relativity isn't real. Like, not so rudely. They're very nice about it. But, you know, relativity isn't real. Antimatter isn't real. All the stuff that is happening in CERN, all of that. They'll all ask me my opinion on it. And I say, well, I don't have an opinion. It just is what it is. Like, oh, but I don't think they really do that. And, you know, yeah, but relativity isn't really real, though. And they'll be lovely, very lovely taxi drivers. But I don't know what it is about taxi drivers and conspiracy theories. I have no idea why. That's my experience with them anyway. That's true. Welcome in. It happens so often. Oh, I'm a mathematician. I hate maths. Yeah. See, if they were clever, they'd just say relativity is negligible, and then we've got a conversation. There we go. They listen to the late night call-in shows. It's a universal thing, is it? Fair enough. Very weird experience. Very, very weird experience. Oh, so some diffusion examples. Heat transfer. Yeah, some really good examples. I should really look through this. The ECG or AKG, electrocardiogram. There's a bit of physics of it. That's kind of nice. The Hall effect with blood. Wow. Electromagnetic blood flow measurement. The rate of blood flow in a body's vessel can be measured using an apparatus. Okay. Oh, because blood velocity induces EMF. Really? Suppose that blood vessel is 2 millimeters in diameter. The magnetic field is 0.08 Tesla, and the measured EMF is 0.1 millivolt. What is the flow velocity of blood? Is that a real thing? That's really, really cool. I assume, but they don't have any evidence that they are just looking get some small talk before they get to your desk. Yeah, sorry, I assume, but don't have any evidence. Sorry. Darth. Sorry, Darth. Wait, how is blood pressure measured? I'm curious now. Oh, I looked into blood pressure recently, actually. How does a blood pressure monitor work? That is a great question. The reason is because I found the blood pressure measurement thing. a really old mechanical one. Blood starts to put tiny vibrations. Yeah. So you basically pump up your arm, you know, you do the mechanical thing, and I'm sure you can feel it, that your arm becomes really, really tense and you feel the blood pumping so much. So what it does is there's a little sensor that actually measures just how much that pumping works. So the idea behind it is if you apply pressure on your artery or your vein, how much pushback occurs because of it. Now, it'd be nice to look at the sensor and everything that actually is in there. That would be cool. The textbook I'm referencing is Giancoli Random. And hear the heartbeat as the pressure increases and decreases. That's right, because that's one way of monitoring. There's like a little mechanical reading. But if you ever go to a doctor, they put the word stethoscope. Doctors also put the stethoscope and they listen to the blood pressure as well. But it'd be nice to look at the sensor in it. Maybe we can build a blood pressure monitor. Giancoli. Hold on, let me. It's not particularly any love for Giancoli or anything. It's just a textbook that I use references. Pretty good. Yes, random. That's where we got just the first one. The other ones we made up. So the first example that we did was from that book, but everything else we what's the word? Our stream de-escalated into some random topics, as one does. Oh, that's cool, Neo. It's really cool to see the pulsing mercury. Yes, that's where I was reading. Yeah, because I have two different versions. I have a physical version that's different to online. Oh, similar idea. Yeah, there's so many cool stuff. Very awesome physics in medical science, which is always fascinating to think about because so many people, what's the word? Just to be a medical physicist is such a broad term. There's no way you can get a degree, a proper degree in that, because there's so much to cover. It's definitely a field of specialization. I suppose like you can make the argument for anything. How do you, Tofu, have a degree in applied physics? There's so many fields in physics. And that's true. I feel like in physics it's kind of easier because you have the core fields of physics, right? Let's say you're doing a degree in applied physics, general physics, astrophysics, whatever. In first year you tend to do general physics subjects, whatever. But basically, most degrees you do about 5-6 subjects a year or a semester. And what you need to cover is the core 5 fields at least once thoroughly. To cover mechanics, cover electromag, thermodynamics, optics, and modern physics. When I say modern, some sort of collective quantum and particle physics in some shape, way, or form. So once you have those 5 covered, like one good module, and many degrees out there will do like thermodynamics 1, physics 2, or mechanics 1, advanced mechanics 2. So you could delve a lot deeper and more thoroughly in these fields. Once you cover those 5, what's really amazing about these degrees Thank you for telling me that, Tarek. What's really amazing about these degrees is that you can actually diversify. You can, okay, I actually don't know how much I'm cut out, so I'll start again there. Double blind testing. So, like I was saying, so there's different degrees in physics that you can get. You can do general physics, applied physics, medical physics. There are all these amazing stuff. And so what's really important is that mostly in first year, whatever those degrees, you do tend to have kind of like a general physics introduction. At least in the first semester, you will do some general physics 1, general physics 2, whatnot. Then you need to just cover 5 important fields in physics. At least one module fully dedicated to them. Mechanics, thermodynamics, optics, electromagnetism, and some sort of modern physics, particle and quantum, introduction to atomic theory, something like that. Once you have those 5 core modules done, that's basically one full semester. Now that's a super intense semester if they're all 5 in one go. But you've done the 5 core fields. Then you can specialize a little bit more. Now, if you're an applied physicist, what tends to happen is they look around your neighboring counties or area and they look at the employment for physicists. So let's say you have a semiconductor company and a microscopy company. So because of that, for employability, for usefulness of the degree, you might have a lot of semiconductor modules and a couple of microscopy modules. They're just trying to cater for employment. If you end up doing theoretical physics, there'll be more heavy stuff on relativity and quantum theory. If you do a astrophysics, there'll be a lot more astrophysics-based modules and so on and so forth. So a general physics degree does cover all 5 very nicely, thoroughly, all those 5 fields, and then you kind of branch off in the specialization of whatever degree of physics you're doing. It's kind of nice. You do still cover good foundation physics if you just do a physics degree university. Now that is, of course, a very general statement. Every university is different. Everyone is going to be unique. No more drink. No, I do not, Daniel. I'm not a big fan of quantum field theory or, look, maybe someday I'll get into general relativity and stuff. To be honest, I am finishing up my electronics series. I've learned almost everything I can. I think the only thing really left to thoroughly study the physics of is op-amps. And after that, I don't have much fire for electronics anymore. Not for doing stuff. I have fun building stuff. But teaching electronics is definitely dying out. I'm pretty much finished covering all the important topics. I'm really delving into thermodynamics again, so I have a lot more thermodynamics. I did upload a video just recently on Bambi. I taught the physics of making a rabbit appear out of a hat. I'll post the link of the video. I thought it was funny when I saw that example. I thought it was very, very witty. But I did buy Griffith's quantum
And they call it a mine.
mechanics textbook.
Mine!
So I might get into more quantum theory again. Maybe. But what's good is that I tend to teach what I'm interested in. And that's kind of good. It's good to teach what you're interested in because you're motivated and you're having fun. So happy enough for that. Hi, Blower. Thank you so much for 15 months. I did have a very good trip. I got a terrible hangover on day 2 of the wedding, unfortunately. Pretty much wasted that day, and because of that. Not a big proclamation, but I've decided I'm going to quit alcohol. Very much so for the time being. No, we're not going to count any neutrinos, Neon. Neo Nitro. So yeah, I still have a few stuff to do in my electronics series. I want to finish... I suppose in AC/DC, the only thing I haven't covered is resonance. So RF, stuff. That could be a video I could do. And then stuff on in algebra, shift registers, flip-flops, that kind of realm. That's the only thing I've left in electronics to do. Once I've covered that, I'm definitely going to finish thermodynamics, or do mostly thermodynamics. But I will have to pick a new field of physics to be into. It might be electromag though. Kind of want to do electromag or quantum. Sure. We'll see. Is the physics part of the stream over? I don't think so. I'm just very hungry. I'm not sure actually what we're doing right now. We did do a whole bunch of maths, but I did want to build Bob. We did want to work out Bob a bit more. A split ring resonator. What's that? Ah, thank you, Daniel. You're very, very kind. Everyone who's had a real hangover is like, I'm quitting hangover until like a week. Yeah, no, absolutely. Absolutely. Although, like, I've had hangovers and I've never said that before. And it wasn't even that bad of a hangover. I wasn't vomiting. I wasn't like, no. I just felt so shit and I needed to sleep all day. Yeah. And I didn't do anything embarrassing. I wasn't a bad drunk or anything like that. Nothing bad to reflect on. It's just, I've noticed that I've gone night clubbing like 2-3 times this year. Just a lot of bachelorettes. And I was quite sober for all of them. I did drink, I just didn't get sloshed. And I had a great time dancing sober. Like, as if I was like drunk with my friends. And I had a great experience being sober. Kind of perceive things differently, and I don't know, I enjoyed it. So maybe not so much as quitting drinking alcohol, but yeah, I'm not up for the feeling of being anymore. We'll see. Oh, okay. Yeah, no interest in that, in the splitting ring resonator. No, random logic. Oh, the Smith chart. They, whatchamacallit, did recently a video. Veritasium did a good video on it. I thought it was quite good anyway. I know a lot of people complained. There was a lot of engineers on it, and they said, oh, finally, a video that even Veritasium can't explain. But I was surprised they said that. I thought it was very good, very well explained. No, I don't do any modding like that, Praise. No, I don't like coding. Oh, that's cool, Random. That is really cool research. It was too fast for me. It is more mathsy than usual Code Shredder, yeah. So if you're not into that stuff, it is a lot. For me, the reason I know the Smith chart is because it's everything I work with. So everything that they covered was very basic to me. And that's not an insult to say that, oh, how did you guys not get it? I've been studying this, I lecture this, so obviously I should know this. But yeah, I thought it was explained quite well. Why are octopus's arms so wiggly? I don't know, Hal. You tell them. Why are your hands so wiggly? How are you doing, Layla? Welcome in. I'm not... It's a mod called Create. Oh, okay. No. I haven't played much Minecraft. Just a little bit of... Not... Yeah, a lot of people have done a lot of the physics stuff in Minecraft. I feel like I wouldn't add much more to it. I think it might be a stressed octopus. Lack of conservation of energy makes it weird. So yeah, I guess we've been streaming for a little while. We could definitely move on to video games already if we want. It's 4:30 now. Yeah, two and a half hours of gameplay isn't bad. I know I wanted to fix Bob. Maybe we'll start with tomorrow's stream with Bob. How do we feel about that? Because poor Bob needs to be done. We made a mistake with the plates. I need to print them actually. I think we edited them, but we didn't print them. Thoughts on how far are we off from practical fusion reactor for energy? I'm not in that field of research, crypto bits, and unless you're a scientist in that realm, you don't really know. And even if they tell you, you don't even really know if it's true. So I don't know if that helps, crypto, sorry. I feel like you should refill your glass. I agree. I keep going to drink and it's empty. I'll make a cup of tea and have a piece of chocolate. Let's have a bit of chocolate. Now, in terms of playing the games, 2 weeks ago I started Kerbal Space Program. It was a bit of fun. So we either continue Kerbal Space Program or we do spin the wheel, play a new game. Because it's been 2 weeks since I played Kerbal Space Program. And yeah, it's been a long time. So I might be a bit rusty. I'm not too crazy into it at the moment. As in, like, it was fun when I played it, but, you know. So what I might do is I might go for a quick break and I might actually make a poll. I know in YouTube you guys are writing stuff, but I have to keep the poll on Twitch. Just because Twitch is my main platform. The bigger platform, sorry. But if anyone on YouTube wants to come over to Twitch, please do. Hey, Preserve!
No, thank you. We don't want any more visitors, well-wishers, or distant relations.
And what about very old friends?
What about very old friends indeed. Thank you so much for the sub. It means so much to me these days. Thank you so much. How are you keeping? Okay, we'll make a poll for 5 minutes. I'm going to take a break here, make a cup of tea. If anyone on YouTube wants to vote, you guys need to jump over. Sorry. No offense taken. 85 stream streak. Let's go. Ah, jeez. That is amazing, Preserve. Thank you. You're very, very good. Wrecking havoc on my sleep lately due to video games. Nice. It must be addicting video games. I'm playing the sheep game, Cult of the Lamb. I got the DLC. It's really fun. The Steam Deck. Okay, guys, I'm gonna go. I would really appreciate if you checked out that new YouTube video with Bambi. And yeah, we're going to go for a quick break. I'll be right back. Of the impedances is a little bit switched from our first equation. Subbing our numbers again. The impedance of one of the capacitors was 50 ohms, so that is why it is not 100 here this time. Again, I'm a bit repeating myself, but you solve it using Pythagoras' theorem, 68.65 ohms. And the angle using tan, which is minus 46.8 degrees. Oh God, when is this going to be all over? We're almost there. We can now put in the angular form where we had the rectangular form. We can multiply the magnitudes, divide them, and add and subtract the angles accordingly. And very similarly as last time, we need to add two polar forms. Let's switch them to rectangular. Something that has minus 90 degrees means that it doesn't have a coordinate in the x direction, so we only have the y, i.e. y is just minus 100 j ohms. Pascal sign and cos to find what the x and y trajectory or the real and complex form. That would be 24.9 and minus 23.27 j. Sub it in, add and subtract like with like. 24.9 ohms remains the same, minus 100 j and minus 23.27. Our Norton impedance becomes 24.9 ohms and minus 123.27 j ohm. We can redraw the circuit like this, where Norton's current and the impedance as a resistor and a capacitor. Or you could add another step and do this in polar form if you wish. But usually in my experience, this is the practice. I hope you found that educational, insightful, and a little bit support, especially for the students taking the courses and modules. This is very mathematical and academic, and sometimes it feels like, oh, why am I even doing this?
More than anything, it's the skills that you develop and you understand how to solve this. When you work in industry, it might take you 10, 20 years before you actually end up using it again. But what's really important is that you develop the skill, and so if you do come across this again, you could relearn and reteach yourself very quickly and solve any problem that you come across. Happy circuiting. Have you ever been asked to calculate the centripetal acceleration of the moon? Probably not, but because we love to do maths and physics, let's do it anyway. The radius of the orbit of the moon is 384,000 kilometers. The period of this orbit, or the time it takes to complete this orbit, is 27.3 days. This corresponds to all the full moon stuff that you know about. Because in everything in physics we work with SI unit, we need to convert 27.3 days into seconds. 24 hours, 60 minutes in an hour, 60 seconds in a minute, 2.36 by 10 to the power of 6 seconds. A very to scale diagram, as you can see. The formula for centripetal acceleration is v squared over r, the linear speed v. V is a distance over time. And we have something. We have the distance, which is the circumference of the orbit, i.e. it going around in a circle, and the time it takes to complete that circuit, 27.3 days. We can sub this equation into v, clean things up here, 1r cancels here and here, and our centripetal acceleration is 2.72 by 10 to the minus 3 meters per second squared. Don't forget the squared. If you want it in terms of g divided by 9.81, which is the acceleration due to gravity on the surface of the Earth, you get 3 by 10 to the minus 4 of a g. Is this going to solve any problems in your life? Probably not, but at least it was interesting and we got some cool facts out of it. Happy orbiting. In electronics, things get complicated. We could end up building a circuit like this. I just put something randomly together, and then we need to plug it into our system. Usually we refer to this as the load. But before we plug it in, we need to make sure that what we're putting across the load is okay, reasonable, and safe. And this is where Thevenin's theorem comes in, where we try to extract what the voltage across that load would be and the resistance that it experiences. We want to get a certain perspective out of our circuit, and we can do that all thanks to a gentleman named Leon Charles Thevenin. Although technically it was actually Helmholtz who developed the original Thevenin's theorem derivation, but Helmholtz was a physicist, and so it was a very physics description, and not many people were able to apply a lot of the knowledge. Thevenin separately developed Thevenin's theorem, where he was the director of Telegraph Engineering School, and supposedly a very good violinist. He passed away in 1926, and it was only right before his deathbed that he realized that people were using his theorem. He had developed it, didn't really think about it at the time, and a friend was visiting him while he was retired and told him that everyone was using his application in circuits. If you know anything about physics, you would know that a lot of people's ideas, theories, and experiments weren't accepted until way past their passing, so at least this has a little bit of a happy ending. Today I will show you how to apply Thevenin's theorem to a classical DC circuit and a classical AC circuit. These examples are a little bit simplified, but the premise can be applied even for complex systems. So let's get cracking. Let's always start with the easy one, DC circuits. Here I have a DC circuit diagram. We have a voltage source, resistor 1, resistor 2, resistor 3, and resistor 4. The load, or the thing that we want to analyze what it is experiencing, will be just RL, a resistor. Most things are just resistors anyway. So our goal is to measure what the voltage is across this area and what the resistance is in this direction. First of all, we're just going to remove the load and measure the voltage across these 2 points. Looking at that diagram, we're basically just measuring the voltage across R2 and R3. You might be saying, wait a second, Tofu, what about R4? The way I like to teach things is applied and practically. Literally grab a voltmeter and measure this circuit. But also, think about what a voltmeter is. It's basically just a giant ass resistor. If you put it across, just have a 580 ohm resistor in series with another giant resistor, let's say infinite size. Infinity plus another number is just infinity. So there is no current being passed through here. Hence, we're only measuring the voltage across these 2 resistors, R2 and R3. So to measure the voltage, it's the classical voltage divider equation. We want to measure what the voltage is across R2 and R3 over the total sum of all the voltage drops. R1, R2, and R3.
Hello, bonjour, I'm back. What were the results of our poll? Your results? Winner is Spin the Wheel New Game. All right. I suppose that's always going to be the win, to be fair. Because one game versus anything is probably not going to do that well. So for people on YouTube, you guys can stick around for Spin the Wheel, but if you want to gamba, the gambos can only happen on Twitch. That doesn't exist on YouTube. So if you guys want to hang out, you're more than welcome to. We might say goodbye to YouTube here. Don't be too offended. If you guys want to come hang out with us, it's Tiny and Toxic Tofu on Twitch. Come, we're cool over here. But yeah, I don't usually stream the video game because it's a different YouTube channel where I upload the video games. Because in my opinion, sometimes when you post on Twitch, when you post gaming on the Science channel, it fucks up the channel. I've found more success on my YouTubes by keeping it physics themed. You sent me something on Discord. Oh my god. Would you look at that, chat? Would you look at that? A vampire drinking tofu. We have a new Halloween emote. What can I say? What can I say? You know that? Sure. Let's pretend it's tomato sauce. Magic. Oh, that's my hair. Thank you so much for this artwork. Jesus, did you get this done in like 2 hours? Because we haven't been talking about vampires that long, have we? Thank you so much, Meje. Well, we said no more alcohol. That is true. I did say I'm quitting alcohol. Didn't say I was quitting blood. Thank you so much, Jay, for that wonderful work of art. We need to add it as a emote soon. Do I have emote slots? General Soak, thank you so much for your prime. Really, really appreciate that. Thank you. Could be a Virgin Blood Mary. So, soup. Tomato soup.